Hello, this is Mrs. Moslake, Geometry Notes 7-4, Parallel Lines and Proportional Parts. As always, go ahead and pause this video to do the warm-up. When you're done, go ahead and play. Okay, answer is E. Who got that? Not as many people as I would have liked to have. We have a smaller right triangle and a bigger right triangle. And it says that they are in a ratio of 2 to 5. What does it say? The hypotenuse is 5 of the small, and how many inches long is the hypotenuse of the larger. So we would set up a proportion because there are similar triangles. So first triangle over second triangle. So first over second, we have 5 over x, and it's in a ratio of 2 to 5. Cross multiply, and it's a really easy problem as long as you set up that proportion correctly, and that's where you get the 12.5. Okay, so we have learned in section 7.2 and 7.3, when you have triangles that are similar, we have 3 similarity statements, justifications. We have either side similarity, angle similarity, which you could also say angle similarity, and side angle side similarity. This section is when you have proportional parts with parallel lines. We can treat those being similar. So triangle proportionality theorem means pieces of the parts of the triangles are proportional. You don't have to memorize the words of this theorem or this formula, just be able to apply it. So let me show you what's going on here. So example 1, RT segment is parallel to VU segment. We know in previous chapters that corresponding angles are congruent when you have parallel lines with transversals. Therefore, these two triangles are similar by angle similarity. So therefore, the parts of these triangles are also proportional. That's what this triangle proportionality theorem says, is that if you have these triangles that are similar, their parts are also proportional to each other. So SV is 3, VR is 8, UT is 12. We want to find SU. So instead of redrawing the two triangles, what you can do now is say 3 corresponds to, normally we would do 3 corresponds to 11, but we're just going to do the parts are proportional. X corresponds to, instead of X corresponds to X plus 12, we're just going to say X corresponds to 12. So the first triangle and the pieces of the second triangle, that's how we're going to set up this proportion. So 3 is to 8 as X is to 12. Cross multiply, and we get our final answer. Divide both sides by, 3 times 12 is 36. Divide by 8, so we get 4.5 or 9/2. And that's our answer. We're done with that problem. You do not have to redraw the triangles when you're using the pieces parts theorem. This is what I call it, the pieces parts theorem. Number 12, this is a trapezoid. Well, we know in a trapezoid, we have one pair of parallel sides. If VS is the mid-segment, it is also parallel to the other pieces. And remember that V is the midpoint of that side, and S is the midpoint of that side. So this is just a review from chapter 6, or mid-segments of a trapezoid. So QR's length is 12, UT's length is 22, find VS. So VS is the mid-segment, so its segment length is the average of the parallel line segments of the trapezoid. So X is, we have 34 divided by 2, so that would be 17. So 17 is our answer. Now, why did I put this in here? Because when you have a mid-segment of a triangle, it works in the same way. So think about this. If I have, this is a midpoint, this is, let's say, a midpoint, and I draw in that mid-segment is also parallel to the base, and it is its length is the average of this length, which is 0, and this length. So it acts almost like the midsegment of a trapezoid. Just think of this segment being 0. So that is what the midsegment triangle theorem says, is that not only is the midsegment of the triangle parallel to its side, but it also is the average of this length, because it's the average of this plus 0. Okay, so that's the midsegment theorem. So let's look at number 3. We don't have to show formulas, just mark up your picture. It says that DE is a midsegment, so that means it's parallel to this piece. And 5, that means that 5 is the average of 0 plus this, so we know that this whole piece is going to be 10. And then I'm going to just change colors so we can see this better. It says that EF is the midsegment of this, so those are parallel. And EF has to be half of 18 because it's the average of 18 and 0. So AB's length is 10, FE's length is 9, and the measure of AFE, let's see, AFE, oh, those are alternate interior angles of, this is our parallel lines with the purple transversal, so it's 87 degrees. So hopefully you felt like this was a pretty easy problem based on knowing your midsegment of a trapezoid. This last part, proportional parts of parallel lines, is just like the triangle proportionality theorem. Whether you have parallel line segments in a triangle or parallel line segments or lines in just a figure, we also have parts are proportional. So let's look at number 4. In the figure, Bulldog, Cedar, and Berg streets are all parallel. So we'll show that. Those are all parallel, so I'll put the arrows here. Okay, and the figure shows the distances in between city blocks. So I'm just going to use a different color to represent the pieces parts. Okay, so 13 corresponds to 26 and 16 corresponds to X. So I'm going to set up my proportion as if there were, the two triangles. They don't have to connect, just like up here. So 13 is to 26 as 16 is to X. Cross multiply. So 16 times 26 is 416. Divide both sides by 13. And 416 divided by 13 is 32. That's all you have to do on this. So hopefully you'll find this section real easy. It's a nice review and quick summary of 7.2 and 7.3. It's also just the shortcut of 7.2 and 7.3 when you have overlapping triangles. At this point, you don't have to redraw the triangles. So enjoy. Again, go back to the video if you have more questions, and make sure that you ask questions if you have it.